Hiya! In today's episode of Bridging to a 7, we'll look at arithmetic sequences and geometry/trigonometry. Let's first look at part A. You have a triangle ABC satisfying the conditions. Pay very close attention to the length of the sides of this triangle. So A is less than B is less than C. So the vertex opposite side A is capital A, and likewise capital B and capital C. We know the angles A, B, and C from an arithmetic sequence. So, in other words, we know that the common difference is equal to angle B minus angle A is equal to angle C minus angle B. Furthermore, we know that the sum of the three angles in this triangle has to be 180 degrees. Therefore, angle A is angle B minus D. Angle C is angle B plus D. The D's cancel out. We can then deduce that angle B has to be 60 degrees. Because of that, the area of a triangle ABC is going to be a half times BC times AB times sine of 60 degrees, or root 3 by 4 times AC. First part of the question done. Second part. Now we're given that A is equal to 2, and sine of A is root 15 divided by 5. We want to find the value of B and the value of C. Part 2 is pretty straightforward. To find the value of B, we simply need to use the sine rule. So, sine of 60 divided by B is equal to sine of A divided by 2. B is therefore 2 sine 60 divided by sine of A. Sine of 60 is root 3 by 2. Sine of A, that's root 15 by 5. So you will get 5 root 3 divided by root 15. You can keep it like that, or you can simplify it a bit further. Root 15, that is root 5 times root 3. And 5 divided by root 5, that is root 5. So B is equal to root 5. We now want to find the value of C. Looking at this triangle, I would say the easiest way is to use the cosine rule. Why is that? Because we don't know the exact value of angle A. So it's very hard for us to calculate the exact value of angle C. And this is a non-calculator question. For cosine rule, we're gonna use angle 60 degrees that we are given. So, AC squared is equal to BC squared plus BA squared minus 2 times BC times BA times cos of 60 degrees. AC squared, that is B squared. B is root 5. BC squared, that's got to be 4. BA squared, BC, BA, cos 60. And now you can solve this equation very easily. You can complete the square or use any other appropriate method. We know that C is the length of AB. Because of that, it has to be positive. So C has to be 1 plus root 2. And this is the end of the question. Part B. The internal angles of an n-sided polygon form an arithmetic sequence with first term 143 and common difference 2 degrees. Given that all of the internal angles are less than 180, find the value of n. Sure. So, we know that the smallest angle is 143. We know that the common difference is 2 degrees. We know that the largest is less than 180. And we know that it's an n-sided polygon. How are we going to use all of these information? One, if it is an n-sided polygon, we know the sum of all the angles in this polygon. In fact, the sum of all the angles is going to be n minus 2 times 180 degrees. This is one of the things that you should know before starting IB, or A level for this matter. We now need to find another expression for the sum of the angles. The smallest one is 143 degrees. The next one is going to be 145, and we're going to keep adding until we get to the last one. How many angles do we have? We have n angles. So, the biggest one is going to be 143 plus 2 times n minus 1. From, from this information, you can then deduce the equation. So, first term plus last term times the number of terms divided by 2 is equal to the equation you would obtain from 1. So I'm just going to quickly simplify this. We can then factorize this equation. The algebra from here should be straightforward. So we have two answers, 18 or 20. And this is where the largest angle will come into play. So if n is equal to 18, the largest angle is going to be 141 plus 2n. So if n is equal to 18, we will get 177 degrees for the case n equals to 18, and 181 in the case n equals to 20. So we have to reject this case, and the only value of n that satisfies the requirement is n equals to 18. Final answer. And this is the end of this week's Pushing to a 7.